All right, so welcome to Research Methods. These are going to be chapters 5, 6, 7, and 8. Just a run through to go over the terms and do maybe a little bit of explaining of things as we go along. So I hope you're all having a good weekend. And this should be, I'll make the video as short as possible because nobody wants to sit in front of a video. But we'll work on that. Okay, so here we go. Chapter 5, Experiments. So what is an experiment? An experiment is attempting to answer a question looking for um, causal relationships, and it's definitely different from correlational research and descriptive research. Um, Experiments look at does X cause Y? So does room temperature affect attention span, as an example? X is the independent variable and Y is the dependent variable. So when I change X, what is the outcome of Y? And so that's another way to look at it. A change in X causes a change in Y. The independent variable, room temperature, the dependent variable is attention span. So if I change the temperature at 60 degrees, 70 degrees, 80 degrees, will there be changes in attention span? One is manipulated, the independent variable, and the other one is the outcome. So there are three main features of an experiment. Manipulation of the independent variable, so having different levels of an independent variable, and there are other variables that are held constant. Random assignment to groups, and that's one of the key things. That's actually what makes it a true experiment. If the independent variable is not manipulated, it's not an experiment. If all other variables are not held constant, it's not an experiment. And so you want to see the specific variable that you want to manipulate. Does that variable have an effect on the other variables? If participants are not randomly assigned to groups, it is not an experiment. It's a quasi-experiment or a different type. You must have all three features in order for it to be an experiment. For each of the following topics, decide whether that topic could be studied using an experimental research design and explain why or why not. So the effect of the parietal lobe damage on people's ability to do basic arithmetic. So what do you think about that? The answer would be no, because you can't damage the parietal lobe and test its different results. That's not ethical, but beyond the ethics of it, it's a constant state. That damage is constant, and so it wouldn't be an experimental design. You could still research that, but you couldn't do an experimental design. The effect B is the effect of being clinically depressed on the number of close friendships people have. And again, you can't manipulate clinically depressed. People are either clinically depressed or they're not, and the degree changes from one person to another, but it tends to stay constant. And so you can look at that, but it's going to be a non-experimental design. C, the effect of group training on the social skills of teenagers with Asperger's syndrome. Okay, and so the independent variable, the effect of group training on social skills of teenagers with Asperger's syndrome. This one can be an experimental design because you can have a control group and you can manipulate the variable group training and measure the effects of social skills on a constant people with Asperger's syndrome. And so those are things that you can control. And it would be an experimental design. The effect of paying people to take an IQ test on their performance of that test. And so you can pay people different amounts So from not paying them anything, right, a control group, to paying $10 or $50 or $100 um, to take an IQ test and looking at their performance on that test. So the test would be um, the measure, but this one's a little bit harder because um, maybe people just like taking tests, so there might be some confounding variables in here that can't really be accounted for without knowing a baseline IQ of the individuals. So this one's a little bit harder to discern because there is a manipulation, right? But then there's also other variables that you can't really control, like their IQ already, without having them measure it. So the researcher systematically changes the level of independent variable across conditions. Sorry. Sorry about that. So the researcher systematically changes the level of IV across conditions. Can be more or less of the IV across conditions, and then can be the presence or the absence of IV independent variable across conditions. So those are the things that people can manipulate to see if there's differences. Holding other variables constant. So variables other than the IV and DV are known as extraneous variables. The only variable that should change is the independent variable. Extraneous variables should be held constant, i.e. controlled. And when an extraneous variable changes with the IV, it is called a confounding variable. Sorry. So, come on. All right. So holding other variables constant. Variables other than the independent variable and dependent variable are known as extraneous variables. The only variable that should change is the independent variable, and the extraneous variable should be held constant. When an extraneous variable changes with the independent variable, it's called a confounding variable. Something's going on with my mouse, so I apologize. When extraneous variables are not held constant, they can become a threat to internal validity. Internal validity is the extent to which independent variable truly had an effect on the dependent variable. If the independent variable had an effect on the dependent variable, then high internal validity. If an extraneous variable had an effect on the dependent variable, then low internal validity. So extraneous variables pose a threat to internal validity in this experiment. So obviously there were many different extraneous variables in that video. Um, Everything from just personal preferences to how she interacted, how she felt about herself when um, she had her different hairstyles. So all of that makes a difference in how other people would perceive it. So as her internal experience changed, so did the external experience. So a good example of extraneous uh, variables. So internal versus external validity. External validity is the extent to which findings can be generalized to people in context beyond the experiment. Why do you think external validity is important? In general, it's important because just like in the video that we saw, they had pretty much Caucasian men and, for the most part, Caucasian children looking at the pictures. And so they talked about it in the video. You know, if it were an ethnic group where curly hair is more common, then that may have made a difference in the perception. So um, it may only apply to certain groups if that's the group that is being experimented upon. So random assignment is what makes it a possibility of an experiment. Random assignment means that each participant has an equal chance of being assigned to each condition. Random assignment is different than random selection. Random assignment minimizes influence of confounding variables on the dependent variable, and therefore minimizes threats to internal validity. And so how that happens is everybody has varying traits. And if their random assignment into each category is equal chances, that kind of levels out the possibility of confounding variables or one group getting one type of trait more than another group. And so overall, it minimizes the influence of confounding variables. So conditions. Conditions are the groups of participants in an experiment. Usually there's two main categories of conditions: treatment or experimental condition and control condition. The treatment condition receives some form of treatment intervention intended to change people's lives for the better. The experimental condition, people receive some form of independent variable, can have multiple experimental conditions, just like we were talking about on concentration and changing the room temperature. There's different levels or different experimental conditions, and one variable is being manipulated. So the control condition is participants do not receive any form of treatment or independent variable. And so they are just a group without the extra change. So types of control conditions, there's the no treatment control condition, a control condition in which participants receive no treatment. Makes sense. A placebo, a treatment that lacks any active ingredient or element that should make it effective. And so people have talked about the positive effect of the placebo, so the placebo effect. The placebo poses a serious problem for researchers who want to determine whether a treatment works. And the waitlist control condition, receive treatment at a later point. Two types of experimental design. There's between subjects design and within subjects design. And this is probably going to be on the test. So the between subjects experiment is an experiment in which each participant is tested in one condition. Participants are randomly assigned to different groups. Treatment A versus treatment B. Participants are randomly assigned to either group. The within subjects experiment is an experiment in which each participant is tested in all conditions. So treatment A versus treatment B, participants are assigned to both groups. Provides the maximum control of extraneous participant variables because it's the same person being tested in each treatment. However, there are disadvantages, and so we'll talk about that. The primary disadvantage of within subjects design is that they can result in carryover effects. A carryover effect is an effect of being tested in one condition on participants' behavior in other conditions, in later conditions. So they may be able to discern what type of things are wanted out of the experiment, and thus what they've learned out of that first treatment may carry over into the second treatment. So types of carryover effects, practice effects. So our participants perform better on a task in later conditions because they have had practice. Makes sense. Depends on what the task is or what the treatment is, but sometimes they have a fatigue effect. Participants perform worse on a task in later conditions because they have become tired or bored of the effect or the task. And context effect. Participants perceive or interpret their task according to the context of the previous tasks. And so they learn the context, and it makes an impact. So how to minimize carryover effects? Counterbalancing is one way. And so systematically varying the order of conditions across participants. So if you have individuals taking all four conditions, maybe there's four conditions, you're going to have them go into taking the conditions. If there are four people in four conditions, they would go, one person would be assigned to 1, 2, 3, 4 condition, 1, condition 2, condition 3, condition 4. The next person might be their route might be 1, 3, 4, 2. Another condition might be 2, 3, 4, 1. And another condition could be 4, 3, 2, 1. And so making it possible to switch up all the different balance the overall outcomes. Two ways to think about what counterbalancing does. It controls the order of conditions so that it is no longer a confounding variable. If there are carryover effects, it makes it possible to detect them. Between subjects versus within subjects. For each of the following topics, list the pros and cons of between subjects versus and within subjects and decide which would be better. You want to test the relative effectiveness of two training programs for running a marathon. And so this would most likely be a between subjects because it takes a long time to train for a marathon. So you'd want to assign a group of people, randomly assign them to group or treatment 1 or training 1, and then randomly assign them to treatment 2 or training program 2. That would be best. Using photographs of people as stimuli, you want to see if smiling people are perceived as more intelligent than people who are not. And so this one, it might be any particular bias that might come from the individuals. You might want to look at individuals going across the same groups. So see if smiling people are perceived more intelligent than people who are not smiling. So have the same individual look at people who are smiling versus people who are not smiling and assess whether or not they seem to be more intelligent. In a field experiment, you want to see if the way a panhandler is dressed, neatly versus sloppily, affects whether or not passersby give him any money. And so this one's a little bit more complex. It could be done actually with either one, between subjects or within subjects, but you're going to most likely go with between subjects. You can be on the same corner, but not necessarily be able to show that the same people go by every day. And is there a difference between neatly and sloppily? But what you could do, and this is something else, it might just depend on the generosity of the individuals that day or what they have in their pocket. So there's a lot of maybe confounding variables in this that is hard to control for, but overall, I think it would be a between subjects, just because you don't know who's going to be there day in and day out. You want to see if concrete nouns, um, for example, dog, are recalled better than abstract nouns, words like truth. And so this you would want to do with probably the same person to see if between individuals, so within subjects design, does the individual themselves have a better recall of dog versus truth? And you could also look at it, the same data too, between subjects. It would work out both ways. So experimenter effects, when the person themselves influences the outcomes of an experiment, these are the experimenter effects. Experimenter bias, when researchers' bias inadvertently affect participants' behavior. Confirmation bias, so is one of those things. I have a belief of an outcome on how it's going to happen, so therefore it's going to be important for me to hold my own expectations out or have other people conduct my research for me. You could have a double-blind research, and that really takes away the experimenter bias, at least with the process of experimentation. Biosocial effects, when experimental characteristics affect participants' behaviors. And then the psychosocial effects, when experimenters' attitude, personality affects participant behaviors. When we do a blind study or a double-blind study, neither the experimenters nor the participants know what the group are in. That's one way to cover or to take care of this. In a single-blind study, the participants do not know what condition they are in. So recruiting your participants, approaches to recruiting participants. Having a formal subject pool, so a list of people that meet whatever the qualifications are for your experiment, and then randomly assigning them to the different groups. Advertising, however, advertising again is you're getting a select group. You get people who are willing to take and sign up for advertisements. Personal appeals, maybe going to the classrooms and recruiting people one-on-one. So if you were conducting a design or an experiment, how would you recruit participants? And that is the chapter 5. So going on to chapter 6, non-experimental research methods. Research methods that do not meet the 3 criteria of an experiment. So if you remember from chapter 5, it's the manipulation of an independent variable, holding extraneous variables constant, and random assignment. Types of non-experimental research: description of a single variable research, i.e. Milgram's obedience study. Independent variable is not manipulated, or no random assignment. All right, so sorry about that. I keep getting phone calls, and I never get phone calls. So the IV, the independent variable, is not manipulated or no random assignment. So correlational research, independent variable is not manipulated and no random assignment. Quasi-experimental research, no random assignment, independent variable is manipulated across different conditions. So the key thing there is they're missing random assignment. And qualitative research is research conducted usually with selected individuals for different traits they possess, and you're collecting rich data. It's not experimental data, though. So non-experimental research and internal validity. Internal validity is compromised because in non-experimental research, extraneous variables are not held constant. And so it lacks a degree of internal validity. In order of lowest internal validity to the highest, we have correlational, which is the lowest. And if you look at it, there's all kinds of correlational information that leads to false um, or or non-attributable outcomes. Quasi-experimental, because there is the only thing it's lacking is random assignment. There's more likely chance that there's going to be influence by the participants themselves. One of the things random assignments does, remember, is it takes and kind of levels out all the different traits of individuals participating in the research, which influences, the amount that it can account for the actual change. And of course, the experimental research is the highest, but it is not without fault either. Correlational research is a non-experimental research. Researchers measure and assess the relationship, and the key word there is relationship, between two variables. Why use correlational research? You do not think that the relationship is causal, or you cannot manipulate the independent variables. So these might be conditions people are born into. So you may look at differences among socioeconomic status. Well, the individuals, especially if you're looking at children, don't have any influence over the economic status, but there may be changes in how education works, right, due to economic status. So those are things that you cannot manipulate the independent variable. The thing that you're looking at, does socioeconomic status influence graduation rates, for instance? And so you can't manipulate that, but there are gradations already naturally occurring. So that would be a time to use correlational research. Variables can be quantitative or categorical. And so relationship between gender, which is categorical, male, female, or other, and verbal fluency, quantitative. So how many words do they understand or are able to reproduce? Or how many words do they use throughout their day between males and females? Relationship between age, quantitative, and verbal fluency. So these are things that you can see are quantitative and quantitative, or categorical and quantitative. Common approaches in correlational research: naturalistic observation, making observations in a natural environment. Pretty self-explanatory. So relationship between country and the pace of life. Using coding, target behaviors are specified and then watched for. So you might use a classroom observation, or you might look at a rural market versus an urban market and look at the differences between the number of people, etc. You're going to use often more than one person rating it, and so you're going to have to rely on inter-rater reliability, and that can be pretty difficult to achieve. You may have remembered that I talked about that before, where there was my own participation in research and trying to achieve inter-rater reliability. It took us a couple of months to achieve it. So lots of training and learning how to look at specific things so that we get those things correct. Another thing is to look at archival data, using data that already has been collected for another purpose. Newspaper, census data, institutional records, hospital records, GPA, right? Lots of different things have occurred. One thing that might be interesting to look at is the impact of the COVID-19 measures and lack of face-to-face education and outcomes in student GPA. For those students who were already in online programs versus those students who had to move to online programs as a result of COVID. That would be pretty cool data to look into. Content analysis and analyzing the content. The number of times nature-based terms are used in a dictionary, things like that. So quasi-experimental, quasi means resembling. Although the independent variable is manipulated, there is no random assignment. School A takes part in after-school tutoring program. That's the treatment condition. School B does not. Control condition. You have no influence over which kids are there because they're already assigned to school. So therefore, there is no random assignment. You are manipulating an independent variable, though, tutoring program versus no tutoring program. Typically used when random assignment is impossible or very difficult, using natural groups. So two types of quasi-experimental research: non-equivalent group designs, between subjects design in which participants have not been randomly assigned, schools A and B in previous example. Pre-test, post-test design. Dependent variable is measured once before the treatment in intervention and once after. So students' understanding of concepts in experimental psychology before, pre-test, and after taking the course. Like within subjects design with no counterbalancing, can't untest. And so you see the two different, you have non-equivalent groups, which is between subjects, and then you have the pre-test, post-test, which is a within subjects design. That may be good for the test. The problems with pre-test and post-test design: carryover effects that cannot be removed with counterbalancing. So you can't affect somebody's history, something that happens outside of the study that has an effect on the participants' behaviors responses. Study of Islamophobia is affected by a terrorist attack. Maturation: participants get better over time due to maturation. Increased school performance in elementary school kids. Regression to the mean, and this is probably something that you want to know too, regression to the mean for the test. Go back to performing as normal after an extreme performance. And then spontaneous remission, tendency to improve over time without intervention. Decrease in mania over time. So those are the different things in that chapter 6. Chapter 7 is research or survey research. So survey research, self-report measures usually. You can do interview with survey, and usually a very large sample size. It's easy to send out an email and have a lot of participants participate in your research. The questions tend to be closed-ended. How old are you, etc. Or open-ended. What do you enjoy about your job? What are the pros and cons of each? So Brousseau, how to write good survey questions. Brief, relevant, unambiguous, specific, and objective are the acronym for Brousseau. And so a poor question for brief is, are you now or have you ever been possessor of a firearm? And effective is, have you ever owned a gun? Nice and short to the point. Relevant, what is your sexual orientation? Do not include this item unless it is clearly relevant to your research. People are less likely to answer or give a socially acceptable answer to questions like that. Unambiguous, are you a gun person? Well, maybe. I mean, I have guns, but I might not necessarily think that everybody needs a gun. So it's better off asking, do you currently own a gun? And how much have you read about the new gun control measure and sales tax? Poor. How much have you read about the new gun control measure? How much have you read about the new sales tax? So the reason why that first one was poor is because you're asking two questions in the same question. Separate the questions and ask them separately. Objective, how do you support the new gun control measure? You're already biased in assuming that they support it. And so what is your view of the new gun control measure? Oh, I support it, I don't support it. So one is giving a lot more an objective perception. And that's one of the ways that experimenter influence over the research can make a difference. by asking that first question, I'm already biasing it. So, creating your own questions. Write a closed-ended and open-ended survey question for each of the following general questions, keeping Brusso in mind. How much does the respondent use Facebook? And so, um, do you use Facebook? Or how many hours do you use Facebook? And then 0 to 1, 1 to 5. And then you want it daily, weekly, etc. How much exercise does the respondent get? So again, just using Brusso, spend some time and just make some questions. So the context effects on survey questions. Context affects responses. Item order effect is when the responses are affected by earlier survey questions. So when you have a question that answers a later question, it's important to understand that they're more likely to get it right. Or if it contains half of it, maybe they're more likely to get it right. So survey formats, in person is always the highest response rate because you might be standing in front of Walmart with permission, getting people to fill out a survey. You're more likely to get people to actually respond because they're right there. Mail, sending that out, it varies a lot, but usually 30 to 35% rates of return, sometimes higher, depends on what group you're sending it out to. Online, mail and online have low response rates. So it's important to remember that. And phone, a lot of government surveys occur over the phone. So people answer the phone and get roped into a 30, 35-minute online or over the phone call. Now, each one of these has what we're going to look at the next slide is biases. So biases in those different methods are making assumptions. So you're assuming by sending out an email that you are sending it out to the people that have email or phones. So it's important, even if you're doing it in person, where you're doing it at makes a difference in the number of people who are going to be able to participate in your survey. So standing at Saks Fifth Avenue doing a survey versus Walmart is probably going to lend to different type of people taking your survey. Sample biases, when the sample is not representative of the population, and non-response bias, those who respond to surveys are inherently different than those who do not. So that's important to remember. And that was survey. So looking specifically at quasi-experimental designs, Chapter 8, Learning Objectives. Explain what quasi-experimental research is and distinguish it clearly from both experimental and correlational. Describe 3 different types of one group quasi-experimental designs. Identify the threats to internal validity associated with each of these designs. So non-equivalent groups designs. So types of designs, one group designs, non-equivalent group designs, post-test only, pre-test, post-test, or interrupted time series. The types of designs for non-equivalent groups, post-test only, pre-test, post-test, interrupted time series, pre-test, post-test with switching replication, and switching replication with treatment removal design. And so Why are control and comparison groups so important? History is an important thing that makes it as part of the ways that the design can get um, confounded. Maturation, of course, either becoming bored, etc. Testing and gives a testing pre-test, post-test. Specifically, can have issues with confounding because of practice effects, etc. The instrumentation you use. Uh, People may do really well on the first test and then do very poorly on the second test through regression to the mean. And then, of course, just people get better over time, spontaneous remission. So these are the different aspects of the groups. We kind of went over it earlier, but those are some of the things that are important in quality. Um, so again, these are the things that different designs, etc. One thing that we didn't go over that I know is on the test is the basically in order to find the effect in a correlational study. So say you have the relationship is 0.90 to the positive. So the effect then is you're going to square the 0.9, and that is going to be 0.81. That is, you're going to have to know how to do that on the test. There's not much as far as, let me see here. I'm going to do a quick review of the test. So if you're still holding on, you'll get to see that, or not get to see the test, but hear the review. All right, so I am looking at the midterm right now, and knowing things like operational definition. Most of the stuff is going to be stuff that we covered in the first weekend, and some of it will be what we just went over. But most of the answers are contained within your key terms. So if you know where to find or how to find those key terms, you should do well on the test. I'm trying to think of as I go through this. So far, everything that I see are terms that are in your key terms. So your study guide for the test would be to know how to find those key terms and then sometimes apply those. And look through your answers. And you might have to look through some of the answers before and see how they apply to the actual question. That's always a key way to take the test as well. Everything is multiple choice. Knowing, of course, the different types of validity and reliability, understanding those definitions, knowing the different levels of variables, so nominal, name or categorical, ordinal, being able to put them in order of some sort, first place, second place, third place. Interval is like temperature, right? Temperature does not have an absolute zero, but temperature does have set intervals between 1 degree to the next as a set space. And then ratio is a degree in number, but also an absolute zero. So age, you are 0 to whatever you are. It has an absolute zero. Temperature, 0 is meaningless because 0 degrees Celsius is not the same as 0 degrees Fahrenheit. So that's not a ratio, that's an interval. Things like that. And one thing that we did not talk about much was the relationship between validity and reliability. In order for something to be valid, it must also be reliable. Something can be reliable but not be valid. And so that's an important distinction. Reliability does not necessarily mean validity, but validity must have reliability. Okay. Let's see. Know the different types of science and who gives authority to what science. That's important to understand. Several questions between validity and internal reliability, etc. Different types of designs, so between subjects within subjects is important. Understanding the stuff we just went over, like the confound, etc. Understanding the difference between the independent variable and the dependent variable, which is just what you just went over. Again, what makes a design experimental versus non-experimental, and what are the different types. So they're going to describe different types of groups, and then you're going to have to figure out which between groups, within subjects, between subjects, you're going to have to figure out which one is the most appropriate answer. So take your time and make sure that you're reading and you understand the different types. Understand the definitions for all the different things that are threats to all the different things that are threats to internal validity. So when I was telling you that if there's a correlation between things, that the strength of the correlation is either positive or negative. And in order to understand what proportion of the variability is accounted for by the relationship, you square that number. So when you do that, that's what I was talking about earlier with the 0.9. The strength of that relationship is 0.9. So that's a really strong positive relationship. And the amount of variability accounted for in that relationship is is 81%. Okay, all you do is double or square the number. So 0.9 squared is 0.81, and that is the answer. 81% of that relationship is accounted for, variability is accounted for by 81% of it. You're going to have to know how to discern the difference in strength and weakness within the correlational relationship. Remember, positive one is as strong as negative one is. It just means that positive relationships means that as x goes up, y goes up. And a negative relationship means as x goes up, y goes down. So that is the main difference. And the strength is on a scale of +1 to -1 for correlational research. And that means that 0.01 is weaker than negative 0.10. That's weaker. Even though it's positive, it's still weaker than the negative. 0.01 is weaker than minus 0.10. Okay, so that's an important concept to understand. And then just knowing, of course, what we went over on the first day of class together was the difference between qualitative and quantitative research. So that is the midterm in review. Everything that you really need to know is all contained within the key terms. So if you understand most of the key terms, you'll do well on most of the tests. And some of it you're going to have to know or be able to look up to get an A or better. So I wish you all luck on your exam, and have a good weekend. Bye.